Good evening, everyone. Okay. Welcome back to Plan 258. Today's agenda, we will discuss about sensitivity analysis, elasticity, maybe break-even points. And I also put the one that you asked us meeting about outlier detection at the bottom of Moodle. Okay. We can also discuss if the time permits. Right. And I would like to remind you about the assignment that you supposed to make in Moodle. Okay. Many of you did not submit yet, but some of you have submitted. So if you have any difficulty, you can contact me. You know my email. You can also contact me via WhatsApp or Facebook Messenger. Okay. Okay. So those who submitted the last assignment, okay, just the last assignment about retirement plan. So okay. So those who got 100 from for this assignment, can you show your work so that the others also understand what's going on? Okay, anyone? Yeah, Jobin.
Hello, sir. Can you hear me po?
Yes, yes,
I'll share my screen, sir.
yes. I think you are already co-host. Yes.
Can you see my screen, sir?
Yes, yes.
Okay. So, based from the assignment, sir, we are tasked to get the total savings for retirement, given that there will be 5,000 per month in this one.
Hmm.
In 20 years of saving with 10% interest per annum. So, for
Mhm.
that first part, sir, here is the brute force computation by turn, sir.
Mhm.
Here's the table, sir. For the savings column, it's just the 5,000 times 12. So it will be yearly. So this is the yearly savings, the first column. Then for the accumulation, it's just the total as of the moment for that year, sir. Then we will get
Hmm.
the interest for that accumulation. This is the interest column, which is we will use the 10% per year.
Mhm.
Then we will get the total for the first year. Then we will move on to the second year. Here's the second year called row. For the accumulation, it's the savings for the at the end of year 2, which is the savings, which is the 5,000, still 5,000 per month, so 60,000 per year. Then we will add the previous accumulated total. I mean the total from the previous year, which is the 66,000. We will come up with the 126,000. Then for the interest, same process as the previous year. We will just get the interest at 10% per annum of the accumulated amount. Then get the sum of these two. Again, the accumulated amount plus the interest. We will get the next the uh, overall total, like the mean the subtotal for that year. So in year 2, the current running total is 138,600. And this process will continue until the 28th year, sir. Okay, so here's the amount after 20 years of saving 5,000 per month at 10% interest per year. Okay,
Okay.
3,780,000, 149.97 using the brute force table. But we
Okay.
can also use the unwitty equation, sir, and we will still get the same value.
Same. Yep.
Yes, sir. I just checked it, sir, so it will be,
Okay.
I have backup plan, sir. Sir, you using without the brute force table, I can show that it is equal, sir.
Very good.
So that's the first part, sir. Then for the 40 years, we will now use the inflation rate since it will affect the inflation will affect after retirement. So here we will start first at year zero. We will use the accumulated amount after 20 years. So I just copied this value, put it here at year zero. Then for the first year, the retirement amount, it's just, sorry, I this the values already the value already used the goal sixer. So that's just say I just use the 5,000 still, sir. I will just use still the 5,000. So it's
Okay.
just retirement. It will be just the same. Uh I mean the amount you will get from the current accumulate I mean your retirement saving times 12. So this will be the total for that year. So what this will be your total retirement money, the 60,000. Then for the accumulation, at year zero, there will be no interest yet, sir. So just blank. So with the accumulation, it's just the accumulation for the previous year plus the interest that you got from that year, the previous year also, minus the one you withdrawn, which is the 60,000, sir. So I will get this accumulated value. Okay, sir. Then for the interest, at year one, since it's already, we already passed 1 year, the effect of the 10% per year will already govern. So I will get this value, sir. The 10% of the accumulated value, I will get this value. Then for the next year, the year two, inflation rate will matter on the retirement money. So it will be increased. The value, the previous year, 60,000. We will multiply it to get with the inflation rate, just like a simple interest formula.
Yep.
Okay, sir. So 60,000 times the 1 plus 0.05. Since it's 5% per year, I will get this value of 63,000. Then sa the accumulation, it's just the previous formula. Accumulated before plus interest before minus the current retirement money. Then we will continue this process until the end of your life. It doesn't matter, sir. It will be infinite if you want to live 100 more years. Since the current withdrawn money is so low, it's 5,000 only. So the last part, sir, for the 40 years is, for example, I will just live for 40 years. I will just use the goal seek add-on, which is from the data. So what if analysis, goal seek. I will set the cell of the row of 40 years, the accumulated money of the 40 years to this. I will highlight this cell. Then I will just set to 0. So this will mean that I will zero my savings or I will get all the money I saved. So that's the value of 0. By changing cell this with the monthly that I will get. So I will highlight the cell where this value will appear. That will be the value of my monthly retirement money that I will withdraw. Then okay. Then okay, it will appear the monthly retirement value. For
16,000.
example, sir, you're just assuming it's not 40 years.
Yeah.
For example, I will just live for 10 years only. So 60
Speaker.
plus 10, so I will just zero this for the same process. I will just zero the 10 years. So I will do again the goal seek. What if analysis, goal seek. I will change this cell to 0 by changing the monthly withdrawal. So there is it.
Good
That's
enough.
the
Yeah. So excellent, Joben. Yeah. So is there anyone else want to comment or you want to show your own work also? Yeah. Okay. Let's see. Oh, you're still mute. So
Can you hear me?
Okay.
I did a Am I audible, sir?
Yeah. Can you
Yeah.
explain?
Okay.
Yeah.
So I did a different approach on this one because I actually divide the annual interest rate by month so that the interest will accumulate or will have an interest every month for every time you save 5,000. That's the idea. So I
Yeah.
divided it by 12. Then you get the 240 or 20 multiplied by 12. And then you get a different amount, of course, because you're
Slightly bigger. Yeah.
yeah, because of the formula for the future value of an ordinary annuity. It's an ordinary annuity.
Yeah.
And then monthly withdrawal amount, I use a different approach again, aside from the previous lesson that Joven also showed earlier. But this one, I use the present value of an ordinary annuity, then just rearrange the formula here. That's why I get this formula. And then you can see it here also, the formula that I rearrange. And then a real rate of return instead of using the 10%, I use the real rate of return of investment yield minus the inflation rate, which is 5%. Well, and then using the formula, I got an 18,000 monthly withdrawal. An 18,000
Oh.
instead of the 16,000 using this formula. And then
Yeah.
the number of years retirement plan will sustain using the um, rearranged formula again of future value of an ordinary annuity. To get the value of n, I just multiply both sides by the rate and also your payment here, so that it will cancel out this one and this one. And then property of logarithm, if logarithm of a raised to b is equals also to b times logarithm of a. So you get this formula also. So you can see that your retirement, if you have a monthly withdrawal of 18,000, it will only last for 150 months or 12.5 years. And then I did the same computation like what others did also. I tried doing it like this. It gained the same value for the
Mhm.
future value or retirement savings after 20 years. So 3.79. Yeah, it just have a different computation as well because monthly the interest rate is applied monthly because of
Yep.
the monthly interest rate as well. And then this is the computation that it will only last for until 33 years. 33 years. Then using goal six per year, this one. But using the same monthly withdrawal as well.
Hmm. So
You need to save at least 5,300. Just a little increase from the original amount of savings, just to make it until 40 years with inclusion with respect to inflation. That's it. Thank you.
I think it's very excellent. Yeah. So okay, super. Anyone want to show also their work? It's okay. Yeah. Or similar. If similar is okay. Yeah. Of course, when you divide by monthly, okay, you will get slightly higher earning. Okay, and if you want more, of course, you can make it daily. Okay. Okay. Thank you, Jopen and Desi. Okay. Okay. So today let's discuss about uh, sensitivity analysis first. Nah? Can you see my slide? Okay. So we will discuss today about three things, okay, on this topic. Okay, sensitivity analysis, elasticity, and uh, revenue maximization. Okay, so this topic usually learned in economic. Probably you already learned, but let's discuss it anyway because some of you did not learn about this topic. Yeah, so sensitivity analysis and elasticity are both technique in economic and decision making, okay, to understand the change, the impact of the change in the input. Okay, so it will help you, okay, to understand how the change in the input variable will affect the output, the outcome, okay, based on certain model or decision analysis. So by doing sensitivity analysis, you will learn, okay, which result that is very sensitive to different scenarios. Okay. And then second, of course, you want to get a better understanding of the relationship between the input and output. Yeah. And probably the most crucial part of sensitivity analysis is to identify, okay, uh, the most influence, yeah, the most influence, okay, yeah, the most influence input variables. Should I share different way or this one? Okay, is it okay now?
Yes,
Okay.
Prof.
Okay. So in sensitivity analysis, you want to know, for example, how much you can increase your product price, okay, without reducing the revenue, okay, or what factor is the most sensitive for your product, okay. So in this case, you can test. Say you have a lot of factors, and then you want to test one by one. In Excel, there is a scenario manager that we learned last meeting. Okay, so you can also use that tool. So this is an example. So as a financial analyst, for example, you want to analyze the impact of interest rate on the interest rate is the input on the profitability of the company. So profitability is the output. Yeah. So for example, the current interest rate is percent, and then the current company profit is 1 million. Of course, there are many other variables as well, yeah, aside from the interest rate. So in this case, because you are focused on one variable, which is interest rate, so you change, yeah, the range of the value. Say this is the current interest rate is 5%, so you increase and decrease. Yeah? So for example, 4%, 5%, and then 6%. Then what will happen to the company profit? Yeah? By doing so, okay, you can check whether this is already significant or the change. Yeah? Of course, you can also combine, okay, several variables. Okay? And for example, oh, the interest rate changed, and then the sales revenue also changed. the tax rate change, what will happen to the profitability. Okay. Another example here is the engineer, for example, want to analyze the stability of the bridge structure. Okay, so you have the, many variables here. Okay. So example, the dimension of the bridge and then the traffic load, the wind load, and so on, including the material. And then what you will do is to introduce very small deviation, or we call it perturbation, okay, to the input variable that you are interested in. Okay, for example, increase of traffic load or slightly change the material properties. What will happen to the response? In this case, the bridge structure, yeah, itself. Then you want to know which factor is the most sensitive. Yeah? Which factor is the most sensitive? Why? Because small change in this input, okay, it will create the largest change in the output. So in this case, what is sensitivity analysis? Yeah, it's just an investigation, okay, about the effect of the small change in the input, okay, in the factor, toward the output, yeah, the system. So mathematically, we can simplify. Okay? So you have a system, okay, as simple as y equal function of x, right? So in this case, y is the output, x is the input. Okay? Of course, there are many other inputs. So, but in this case, we are focusing only one factor, which is x. F is the system or the function. So when we said sensitivity analysis, we want to know the effect of the change, that small change, so delta x toward the output, which is delta y. Okay, so that is the meaning of sensitivity analysis. So the step of doing sensitivity analysis is, of course, number one, you decide which variable, okay, and which model or methodology that you want to test. Okay, and then you select one or two, probably, independent variables that you want to change. Okay, and of course, you divide the output. Okay, what is the base case scenario? Okay, after that, you adjust one of these input while keeping all the other input at the same baseline. Okay, and then check this effect of this change, and then you can also calculate the percentage of the change. Okay, and then repeat the same thing for other input variables. Okay, let's say you have a demand function. Okay, y is represent the demand of certain products. You say, for example, the product is banana. Okay, in this case, Y represent the number of banana that people want to buy in that small village market within 1 month. Okay? So demand is usually flow. So that means the amount divided by time. Okay. So now X in this case is the price, for example, price of the banana in the market. Okay. Now, if we do sensitivity analysis, okay, so we want to know, okay, how sensitive the value of the output, right, due to the change of the input X. Okay. In this case, we want to know, okay, if the small change in the price, okay, X a while ago is price, right? So, what will happen to the demand? Okay, so if the small change in price lead to large change in demand, so we said, oh, this demand function is sensitive. Yeah, but if the change in price does not affect so much in the demand, so we said this demand function is not so sensitive to price. Okay, application to transportation, for example, you want to increase the bus fare or the MRT fare, okay, increase a little bit. Right? So then you want to know what is the effect to the demand. How many passenger will still join? Okay. So This is important issue, isn't it? Okay. So let's say you have this kind of function. This is the say demand function. So when you do sensitivity analysis, you always have the base case. In this case, you always know the x0 and the y0. Okay? And then now you want to change. Okay? That means you apply that change. Delta x is the x1 minus x0. Okay? So you change a little bit to the left or to the right. Okay? And then you will get y1 as the output. So then the sensitivity is as simple as the slope. So delta y divided by delta x. Okay? So the change in the output divided by the change in the input, right? So now if x in here is a price and then y is a demand, then the price sensitivity simply you get the by dividing the percentage change in the quantity, okay, and then divided by the percentage of change in the price. Okay. Not the same as sensitivity. We will discuss sensitivity after this. A little bit different. Okay. Okay. So the sensitivity is just a change. So if you increase the price, for example, by 50%, okay, and then the sales drop by 12%, so then price sensitivity is just that value, okay, which is say 0.24. Okay, that means what? Every percent the price increase, okay, it will impact the amount of purchase, about how many? 25%, okay, in this case. So any sensitivity analysis, you need to get the base value. So what is base value? The current price. Okay. So and the current demand. So say for example, you know the average price of banana is around x0. Okay. So here, okay. And then you also know the current demand, right? You're already doing this business. So in this case, you have y0 as the current average demand. So the coordinate x0, y0 is called the base value of the sensitivity analysis. Okay, and then now you want to try. Okay, what happens if I increase my price of banana from x0 to x1? Okay. Assuming you already know the demand function. This is the most important assumption. So now, because you already know the demand function, okay, then you can calculate, okay, if I change this to x1, you will get y1. Okay. So the way I do sensitivity analysis is to create what is called sensitivity graph. Okay. So I call this so I created a simple way, okay, to do that by creating a ratio between x1 and x0. Okay. And then in the vertical axis, you calculate the delta y, which is y0 minus y1 minus y0. Okay. Then we can plot. Okay. We can plot a sensitivity graph, which is the sensitivity function of that original demand function. Now become delta y versus k, like this. So that original Riemann function is y and x. Now you have a k ratio, which is x1 divided by x0, and then compared to the delta y. So what's the good thing about this? So by transforming the original demand function to sensitivity graph, now you can get how sensitive the demand function simply by checking the slope. of that sensitivity graph. Okay, and using this, you can see easier. Okay? So if the slope is large, that means this is the part that is sensitive. Yeah? If the slope is low, not so large, then this is the demand function is not sensitive. So these are the characteristic of sensitivity graph. Okay? Always you can get the base value, right? Which is the x1 equal to x0. In this case, you will get 100%. Okay, right? And then at that point, the delta y is 0 because y1 is now become y0. Okay, so that is the base value. Okay, and then from there you can check to the left and to the right. Okay, so as an example, and probably your practice. Okay, so suppose we know this demand function. Okay, so y equal to 2000 of x is the current price. Okay, and then say certain exponent here. Now given the average current price is say $2, okay, inputting this $2 into the y, okay, you can get the y0. Okay, so now can you plot the demand function and the sensitivity graph? Okay, so this is the way to do in spreadsheet. Okay. So I get x here. This is the demand function is y. Okay, and then you can calculate the k value, which is the x1 divided by x0. X0 is already given above in the red, in the yellow here. Okay, and then you can calculate the delta y. Okay, from there now you can plot the two of them. Okay, so let's practice this for a while. Okay. Once you finish, you can show your plot.
-0.25. I will
Okay,
get the
sorry.
price, then we will plot this two two columns. So I will using the scatter plot, sir. I get this demand function, sir. The price is at the left, then the x values at the bottom axis, sir.
Yeah.
Then for the sensitivity graph, sir, we get the k value. So x formula is the change,
X
sir.
divided.
Yeah, the
Yes.
x1 over x naught.
X1 divided by x0.
X naught, x0 or x naught. So I will just do that for every values of x1, then all throughout. Doesn't matter. It's up to you where you will answer. Then the delta y is just the value of the y1, the y1 minus the our control or the base value.
Correct.
Then after that, we will just highlight these two columns, and we will do the scatter plot. It will give this graph, sir.
Okay. So now, can you check the sensitivity graph? Okay. Imagine you create a line. Yeah? So which part is actually the most sensitive part there? So a straight line. So of course the largest tangent. Okay.
This one, sir. Around here.
Yes. No, the actually let me annotate. So to get the line. Okay. So here, can I draw here? This is the tangent, right? Okay.
Yes,
And
sir.
then now suppose this is the tangent here. So the tangent here. So which one is higher? Of course, this one is higher, isn't it?
Leftmost. Yes, sir.
On the leftmost. Okay. So that means this demand function, okay, is the most sensitive when the price is low. Okay. And when the price is already large, okay, it's no longer sensitive. Okay. So at least we know the behavior based on this sensitivity graph. Okay, thank you, Japan. Okay, anyone else want to share screen? Or if you have any difficulty, no problem to share so that we can do it together. So for this part of sensitivity analysis, you can start to see, okay, what's the difference this with elasticity later. Okay, elasticity is the change itself, the change divided by the change. But in terms of sensitivity, we want to know the actual tangent, okay, rather than so the tangent of the input divided by the tangent of the output, or the output divided by the input. Yeah. Okay, so let's continue this with the next part. Okay, you already did this. So the next part is the revenue maximization. Okay, so a while ago we said that look, the price increase. So if the price increase, the demand reduce, isn't it? This is the magic, yeah. The price increase, demand reduce. How about the revenue? Okay, the revenue can be going up, can be going down, right? So when we say revenue, is the multiplication, okay, of demand multiplied by the price, right? So this is the formula, okay. So if X is the price, okay, Y is the demand, so revenue is just X times Y. Okay, so say your banana that you can sell per month is reduced, okay, but it doesn't mean that revenue is reduced. So in that case, how can we, because this is variable, so can we maximize? Okay? Can we maximize? Yes, we can maximize that using calculus. Huh? Okay, so knowing the demand function, this is very important to know the demand function. Okay, so you can do sensitivity analysis, okay, and then you can change the price, okay, in some way. Of course, you want to reach the highest income or the highest revenue. Okay, so this is called revenue maximization. Okay. Remember, revenue is the same as price multiplied by the demand. Yeah? Quantity sold is the demand. So in this case, you have also the change in the revenue. We call it marginal revenue. Okay, is just the change in the total revenue divided by the change in quantity sold. It is the change in demand. Okay, so when we say revenue maximization, then we set this marginal revenue equal to 0. Okay, let's take the example. Okay, suppose your demand function, say, is linear. Okay, so y is the demand. Okay, 6 minus 4 times x is the price. So, and you also know the current price, which is $0.25 per item. Okay, so you input that into demand function, right? So 0.25 multiplied by 4. So 6 minus 4 times 0.25, it is 1. So y0 is 5. Okay, now we want to know what is the price that maximizes the revenue. So in this case, you can, of course, you can take the first derivative. If you want to use Excel, you can do it this way. Huh? So again, similar to a while ago. So in this case, now you add, okay, this column of revenue, Okay, uh, it is x multiplied by y. Okay, now you can see that the plot, okay, of the demand, revenue and price is actually quadratic. Okay, then you can find the optimum here. The maximum revenue will happen at certain price, right? Okay, so how to compute that? We take the, okay, we use calculus because we know the demand function. Okay. Okay. So because this is your demand function, okay, then the revenue is, this is a linear function, right? Y equal mx plus c. So this is a linear straight line. Okay? And then multiply by x. So you get quadratic function of the revenue. And then now you want to get the marginal revenue. So you take the first derivative. Okay, so it becomes 2m times x plus c. Yeah? And then equate this to 0. Yeah? So then you can c is on the right side, left hand side, and then you can get the x. X is minus 2c divided by m, 2m. Okay, in this case, $0.75. Yeah. So at that time, the y is 3 items, so the revenue is 2.25. So this can be seen also in the Excel. Okay, so this is the red line here represent the new price. Okay, this is the green line here is the current price, 0.25. Okay, if you want to uh, improve your revenue to be maximized, so you need to increase it. Okay, from 0.25 now become 0.75. And strangely, yes, the demand reduce when you increase the price, okay, but okay, but the revenue is maximized. Okay, so until here, any comment, question? Can you do this? So, Chopin already showed that a while ago. So, can anyone else also doing now about the revenue maximization in your Excel? Hmm? Anyone? Oh, how is your calculus? Have you ever learned about derivative? Not at all, even in undergrad. In high school, did you learn? Okay, so anyway, the demand function here is always simple. So I think this is like high school level calculus. I guess you can do it. Right? just power polynomial only. So not really complicated. Yeah, if you cannot do calculus, no problem. You just use Excel. Okay, you will get the same result. Yeah, but using calculus is faster and more exact. That's the point. Yeah. And anyone want to show? Okay. Those who already did the linear model, okay, can you also try with power curve, yeah? Power demand curve. So this one. So instead of linear, a while ago is linear, right? Something like this, right? Linear, right? This is the linear demand function. So what happens if now the demand function is not linear, but power curve like this. So 2000 x exponent minus 0.35, the one that you did a while ago. So what happened to the maximizing revenue? This is also another interesting problem. Yes, Johan.
Sir, I use the Excel platform.
Okay, no problem. Go ahead. Okay, you want to share your screen? Okay,
Yes,
this
sir.
is
Yes,
the power curve, no? The power curve.
yes, sir.
Okay.
Sir, I just, with the formula R is equal to XY, I just get the
Correct.
value of all R's.
Okay.
Then plot
And what happened?
X versus R. Sir, unlike a while ago, there's a concavity. So we can get the
Correct.
maximum if there's concavity. Unlike this example, it's always going up if we continue this trend.
Correct. Correct. So when you're if you identify the demand is to be a power curve like this, okay, that means you can increase indefinitely, right? So that means you have the power of monopoly.
Right. You just
Okay, then you
increase
can
everything.
ask. Yes, you can always increase whatever you want. So the only thing that you economically, yeah, based on the price only, yeah. So the only thing that probably prevent you to become a monopoly is probably government or the rebellion of the people. Okay. Uh, at least technically, so you know. Okay. So then the next question probably you ask, how do I know the demand curve? Well, you can get the price and you can simulate, no? So what happened to if I change this price and what is the response of the people? Okay. In terms of the demand, you can measure anyway, right? Demand is just the flow, how many product you sell in certain amount of time. Okay, for example, per month or per week or per day. Okay, and then from there, if you have several points, then you can do a regression, isn't it? So then from the regression analysis, you know the demand curve. Okay, once you know the demand curve, what you will do, you do sensitivity analysis. Okay, you know which part is the sensitive part, and then the second, you do this revenue maximization. Interesting, nah? Okay, so I hope this give you some insight. Okay, not everything can be maximized. No? Yeah. Okay. So, any question? Can I get your feedback about this topic? Is there anything that you understand or you don't understand? No problem. So, give me feedback. What did you learn? Come on.
Hello, sir.
Yes, Genevieve. Yes.
Actually, this is quite new to me since
Oh,
in
okay.
undergraduate we only had like the simplest, I think, calculus and for economics.
Okay.
I'm not really, and my background is not really engineering or architecture or economics. I'm a
No, no
community
problem.
development graduate, so
Okay.
it's actually very new and very interesting for me because it's there's a lot of ways to solve this. For example, this uh, the demand the demand elasticity. So it's quite new and very, although it's hard, it's actually hard for me
Okay.
uh to follow the activities since it's, well, I don't know how to use this in Excel. So I think it's helpful. It's
Okay.
very
Ask
helpful.
Joven. Ask Joven to help you.
Yeah, they're very fast actually. So uh well, I get to
Right.
learn from their examples because during the classes it's still hard for me to understand how to use it in Excel. But with the
Okay.
examples provided by my
Yeah.
classmates here, it's easier for me.
Correct. I think we also have the video recording, so you can also check that. Okay, if you have some problem. Okay. Yeah. Thank you for sharing this problem. I hope you are okay. Uh,
Trying to be okay.
right. Most important is motivation. Okay. So is this very important and for you or not? Okay. So if you think that this is very interesting and important, of course you want to maximize your revenue, isn't it? Don't you want? Okay. So in that case, you need to learn
I
about
think,
this
sir, this
more
is,
detail.
sorry.
Yeah. So go ahead, Genevieve. Yes.
I think, sir, it's actually very helpful since in our work, I also have to use some of the, like, for example, doing proposals and researches. So this would be easier for me if I know how to do this in Excel, even the simplest way.
Okay.
I think it's very helpful with me for my proposals, more
So
valid
keep your
proposals. Yeah.
keep your spirit high. Okay. Yes. Okay. Anyone else want to say something? Think. Okay. So let's continue in that case. To this part. So when your demand function is actually a different curve, yeah, based on your regression analysis and so on. Okay. So yeah, uh, in this case, the higher price will always produce higher revenue. Yeah? So if you plot the revenue versus price, okay, so in this case, price should be determined by other factors, yeah, not based on demand function alone. Yeah. Mathematically, okay, so if you have a demand curve like this, right, so you you can calculate the revenue, okay, and then you take the marginal revenue, which is the first derivative, and set them to zero. Okay, because this parameter a and b are not zero, then the only way to do this is when x is zero. But this is not maximization, so this is actually minimum. Okay, so you can see that from the plot. Okay, okay. The price, the revenue will be minimized. Okay, so when you do calculus and set the first derivative to zero, there are actually two possibilities, or maybe three possibilities. One is called maximization. One second is minimization, okay, and then the third one is saddle point. Okay? So this is what we learn in calculus. Okay, but if you want to know more detail, then you need to get the second derivative of this. Anyway, in this case, for the demand curve, of power demand curve, okay, there is no maximum. Okay, there is only a minimum. Okay, and for linear, this is what we did a while ago. So we can easily get uh, the price, okay, based on the value of A and B, okay, of the demand function. Yeah? A and B are the parameter. Okay. Next topic. Okay, this is what Resi was asking a while ago. Is about price elasticity of demand. Okay, so then you ask, what's the difference? Okay, a while ago asking, what's the difference between sensitivity and elasticity? Here it's the difference. Okay, sensitivity is just the slope. Okay, dy dx. Okay. The elasticity is the slope divided by the slope and the actual value. So elasticity E is actually dy divided by y and then dx divided by x. Okay, in that case, you can put them here. Okay, and then that's exactly the same as sensitivity multiplied by x divided by y. So sensitivity have units. Okay, because this is a slope, this is a change, so it has unit. But elasticity, okay, it has no unit because they are actually the same. Okay, so the price elasticity of the demand, okay, does not change when the unit of the price or the unit of the demand change. Okay, so you may ask, what is that for? Okay, why we need to make so complicated formula like this? Right? But this is actually very useful. Okay, in a moment. Okay, so the price elasticity of demand reflect how much a good or service, okay, the buyer will consume, okay, when the price increase or decrease. Okay, and not only that, okay, price elasticity of the demand is actually uh, a good indicator, okay, whether your good or service is actually a necessity, replaceable, or replaceable by substitute. Yeah? So depending on the value of the elasticity, this E, okay, then you can categorize, okay, into three, okay, three types. When the elasticity is, okay, because this is a change, right? So this must be negative. So if the value is negative E is larger than 1, yeah, that means your product is actually unnecessary. Okay, so why? Because the change in price is actually larger than the change in demand. Okay, so that means the increase in price will reduce the revenue. Okay, why? Again, because mathematically the marginal revenue a while ago is positive. Okay, the second part is unitary. That means exactly one. Yeah, elasticity exactly one. Okay, so this is rare, but anyway, this is like the boundary. So uh, that what's the meaning? That means the change in price, okay, will have equal to the change in demand. So in this case, the increase in the price does not change the revenue, okay, because it is exactly the offset of the same amount of demand. Yeah. So in this case, the marginal revenue is exactly 0. And the third one is your product or your service is actually inelastic. Yeah. That means your minus E is between 0 to 1. Okay. So your product or your service is essential. Okay. So change in price is actually smaller than the change in demand. Okay. And your marginal revenue is negative. This is all the same thing. Okay. So let me give more detail about this. Yeah. So elastic demand is the first part here. Okay? Unnecessary. Okay. That means when the price goes up or go down, okay, the customer habits will change so much. Very sensitive. In that case, when why we change so much? Because elastic means unnecessary. Yeah? Your product is easily replaced by substitute. Yeah? So clothing, electronics, probably. Okay. So luxury items, when the price increase or decrease, the change is so much. So if you increase the price, okay, they will go to other substitute products. Okay. So companies like airline industry, which is very highly competitive, okay, usually offer service and product. It is actually elastic. Yeah? So if the airline increase the fare, yeah, it will see the decrease in the demand service. And then why? Because the customer can choose another airlines. Okay? So free competition. Okay. So if your product or your demand is actually elastic, probably you don't want to change the price. Okay. You know, right? Now, how about the supply? Okay. If your supply, okay, is elastic, yeah, that means if the market price of elastic good decrease, the firm is likely to reduce the number of goods they are willing to supply. Okay. Now, if the market price goes up, okay, the firm is likely to increase the number of goods they are willing to. So, okay. Next, what happens if the demand is actually inelastic? Okay. That means this is essential items. Okay. For example, medication, food, gasoline, electricity. Okay. They are inelastic. Okay. So that means when the price goes up, okay, or goes down, the, the amount of demand, the habit of customers still the same. Yeah. Insensitive. Okay. So essential items. Is it clear or not? Okay. Now, test. Can anyone calculate this? When the price goes from your good, for example, your banana, okay, okay, banana is too expensive for $5. Anyway, so when the price of a good went from $5 to $8, say increased 60%, okay, the demand went from 100 units to only 17 units. Okay? So the question is this elastic or inelastic? Can anyone compute that? So, so the price, okay, changed from $5 to $8. Okay. The demand down from 100 to 70. Yeah, in terms of transportation, for example, you increase the fare, right? Okay. For public transport, for example, price increase, okay, and then how many people will still use the public transport? The same thing. So gasoline price increase. Oh, this is easy to check, no? Because gasoline in the Philippines is going up and down. So that's easy to check. And then you can see the demand. Okay. How many people buy within certain amount of time? Say 1 week. Then you can check whether the demand, okay, elasticity is elastic or inelastic. Yeah? Anyone? Calculate by hand or
Sir,
hmm?
I think it's inelastic.
Okay, what is the elasticity? Christine?
Negative 0.5.
Yes, negative 0.5, correct. So, okay, so because this negative 0.5 is between 0 to 1, okay, so if you put minus E, then this is correct. This is an elastic, yeah. So, okay. So knowing the elasticity alone, okay, you can already check, yeah, this is inelastic. That means, oh, this good is a necessity, essential. Interesting, huh? So you know the characteristic, okay, based on these numbers. Okay. Okay. So now discussion. How about this? Education is elastic or inelastic? Remember, yeah, inelastic mean necessity. Elastic mean unnecessary luxury goods. So how about public transport? Elastic or inelastic to the change of fare? How about parking on campus? Okay, if you need to pay the parking fee on campus, is it elastic or inelastic? Any idea? Yes, Aaron.
Um, Sir, I think for education, in general, it's supposed to be an inelastic good because it's an essential good or services. However, if we put into context the financial capacity of the person, it might be elastic. So if or inelastic. So if you are, let's say, from a well-off family, um, even if the cost of education is so high, your demand for education would still be the same. But if
Mhm.
you are from a not so well-off family, um, if the cost of education goes very high, your demand for education would go low.
Mhm. So education is necessity, you are telling,
Yes, sir.
right? So inelastic. So in that case, you can categorize. Yeah? Not all education are inelastic. No? So there are certain things that you can package. Okay, you can package certain education to be uh, necessity, and you can package certain education to be luxury. Okay. So how about public transport?
For public transport, it says here, if you are a captive user, so I guess it means you don't have a choice, right?
Correct.
So it's supposed to be an inelastic demand to
Inelastic.
the change of fare. But if you
Right.
have a choice, if you're a
Then
choice
become
user, it will be
yes.
elastic.
Yes. Captive user mean they don't have private vehicles. No? They don't have motorcycle. They don't have car. So that is captive user. If choice, that means they have their own private vehicles. Okay. How about demand on parking on campus?
I think, sir, that would also depend if you're a captive user or a choice user.
Correct. So, or probably if online course like this is allowed or not, right?
Yes, sir.
Oh, did you fill up the survey? Okay, so I think they want to change. Okay, so good. So let's continue this. Nah? So say you have Now I combine the concept of elasticity now with the demand function. Okay. Okay. Suppose you already know the demand function is this linear. Okay. Y equal to minus 5x plus 100. Okay. And then the x0 and y0 is also given here, 15 and 25. Okay. Then what is the elasticity of the demand? If we want to change the price from 15 to, oh, slightly reduced, so 14.8. Okay. Can anyone compute this? So is this elastic or inelastic? Yeah? What is the elasticity value? Okay. What kind of good this firm is selling? Something like this. Okay, try to do it. I will pause. Go ahead, Katrina. You can share your screen.
Can you see my screen?
Yeah, yes.
Okay. So, sir, this is my calculation. So, I input the price at the start, which is X, and then
15.
second price, and then difference, which is DX, and then I input the demand function, and then dy is the difference between the demand at the end and the start, and then calculated for the elasticity. So the value is, the absolute value of this is
Yeah,
greater
3.
than 1.
Yes.
Which is
So in that case, elastic good.
Mhm.
Yeah. So the 3 in here means when the price decreased by, because negative, right? When the price decreased by 1%, so the demand increased by 3%. Okay. Yeah, excellent. Yeah. Thank you, Katrina. So this is interesting. So you can, from the demand function a while ago, okay, you learn about sensitivity analysis. Yeah? And then you learn about demand function. Okay. Now we continue that, okay, with elasticity. Right? So that means now not only you can maximize the revenue, now you also understand the behavior of your goods or your service. Okay. By knowing the elasticity, yeah, you understand how many percent change in the price it will change in terms of demand. That's the meaning of elasticity. Yeah. So let's practice one more. Okay. Okay. What happened if your demand function is power curve again? Okay, remember the power curve a while ago? We cannot find the maximum revenue, right? So it's always up. What happened? Okay, let's continue with our banana function. Okay, so say the power function is the same as before. Okay, 2000 x minus 0.25. The same again, average current price is 2. Okay, now can you now calculate the elasticity of the demand? Okay, is banana elastic or inelastic? Yeah, Jovin, go ahead. You can share your screen. Oh,
Hello, sir.
yes.
For
So
example,
calculate the
sir, I
x
just want to increase the price at for any percent,
1%.
random
Okay.
percent.
Okay.
So the value of the new x or x1 is 2.02. Then
Mhm.
inputting it to 2000 times x raised to negative 1/4, I
Mhm.
will get this value. Then we will get the delta x, which is x1 minus x not the control, 2 minus
Mhm.
2.02. Then delta y, it is negative since the value of y 1 is smaller than the original. So I get the sensitivity. It's a
Mhm.
negative value. Then since it's a negative value, then the value elasticity is the slope s
Okay.
times the original ratio of x and y.
And y.
I get
Correct.
then I get this value, sir. So
Yep.
interpretation is
Which
essential.
is between 0 and 1. Yeah.
Yes, sir.
Yeah. So this is essential. Okay. So
Yes, sir.
very good. Excellent. No? So we know, okay, based on this okay curve that you can collect the data, okay, and based on the initial value of x and y, and then if you want to change, what will happen, and then you can also check, okay, whether this is essential or unnecessary, yeah, unnecessity, right? Excellent, yeah. Okay, so then you may ask, how I will uh, use this in transportation. Okay, yeah, of course you can not the factor is not always price. Okay, so one factor is of course you can change the price. For example, toll fee, okay, congestion charge, okay, and fare of the public transport or gasoline price. Okay, so but you can also check in terms of uh, trade-off between the revenue, okay, and uh, when you increase the revenue, okay, and the other things. Now, for example, how about the modal speed, mode shift, okay, how how about the equity consideration, okay, how this will the change in the price will actually affect different social economic groups, okay. So then you make adjustment, okay, for example, for the fare for uh, different socioeconomic group, okay, to ensure the fairness and to minimize the potential negative impact, yeah, for local population. Okay, with that, we finished the first part of our lesson today. So, is there any question, discussion, or what? Tell me what did you learn? Give me feedback before we go to the next topic. Do you still have energy to go to the next topic? Okay, the next topic is actually interesting. Okay, so this is based on my book. Yeah. So the next topic is about BEP analysis. Can you go to Moodle and download the BEP analysis? Yeah? You probably learned BEP analysis. I know. Okay, but what I want to present here is probably something new. Okay, so close this sensitivity analysis, and let's go to BEP. Hmm. Excuse me. Can you see my slide? Or can you see the slide? Break-even point. Okay. So let's start. Did you download the slides? Okay. So these are the topic. Okay. Of course, the first part is the usual, the break-even point and the what is fixed cost and variable cost. Okay. This is the basic. No? Then let's continue that. Okay, with the gross margin, okay, and then the BEP analysis itself. And I continue. Okay, so suppose imagine that you are doing a business. Okay, in this topic, I hope you can think that you are doing a business. Okay, well, of course, you can also think if you are a government officer, you should have a business thinking, right? So of course not for the business itself, probably for the revenue of the government or for the good of the people. Okay, so but for a moment, just think that you are a business people. Okay, you want to know, okay, whether you can get profit or not. BEP analysis, and then we will discuss about the required capital and cash flow. This is the most important part. Why some business bankrupt? It will explain, yeah, why some business bankrupt. Okay, and you will surprise probably. Business bankrupt not because they don't make profit, yeah, but because the number of cash flow is not enough. Okay, and most importantly, the insight from this topic is actually the risk transfer. Okay, the risk transfer. Okay, and we can measure that risk. The non-linear BEP is the optional part of this topic. Okay, let's start. So what is BEP or break-even point? Yeah, break-even point is just a point here. Okay, so this is the point okay, where the revenue is exactly the same as total cost. So you have revenue equal to total cost. That is a definition, BEP. So do you like, if you are a business, do you like to have no profit and not loss also? No, you don't. You don't like. Okay. So BEP point is not something that you like. This is important first lesson. Okay. When you calculate BEP does not mean that this is something that you like. This is just an equilibrium point. Okay. The minimum that you neither loss or profit. Okay. Okay. Next, why we want to study BEP, right? So, oh, many reasons, yeah? Many reasons. So, one reason is you want to identify what is my level of sales, okay, in the business just to cover the cost. Okay. At least I know that, then I need to go beyond that, right? Okay. And then second is to determine the product pricing. So BEP analysis is so important that you probably need to decide these things and product pricing almost daily, okay, depending on the current demands, right? So put this in your calculator, okay? Third is, of course, to know the minimum number of soils, okay, to cope with the current demand, because the demand is fluctuating, right, up and down. Okay? You cannot control the demand, but you can control the sales. So in that case, you need to know what is the minimum number of sales. Okay. Next, this is important. Okay, we will discuss about there is a risk, yeah, transfer from employer to employees and vice versa. Okay, based on this concept, okay, of BEP. Okay, this is what majority of people don't understand. Okay, so there's actually a risk transfer. Later we will discuss about this, yeah, in more detail. Next, what is the why we want to do, why we want to study BEP? Of course, say you pay marketer, right? So you have a business, you pay a marketer, okay, a certain amount. What is the target that you need to set to that marketer? Okay, to know the revenue, okay, the target revenue that that marketer should bring to you, okay, to cover, just to cover his or her salary. Okay. Next, based on this BEP analysis, you also will be able to determine what is the minimum capital if you want to make your business viable, and what is the minimum cash flow. Okay. If you minimum in if you don't have this capital, you cannot do this business. No. Okay. The same thing. Yeah. What is the minimum price? If you have a different capital, okay, their price will be different. Okay. And then we are asking, what is the minimum price based on the capital that you have? Based on that, later you will study, oh, what is the difference between small trader and large distributor? Okay. Why the large distributor can make its price lower? Okay. And next, this is what makes the business bankrupt is the delay of payment, the cash flow. Okay. Even though you make profit, but your customer pay you later, you have a delay, and it can make bankruptcy. Yeah, the delay. So how we will include the time in that BEP? So this is I hope this is interesting topic. If we cannot finish, so until next meeting. Yeah. So if we can finish, we can. I hope. The most important is you should understand this, okay? Because this is very interesting topic. Okay, let's go. So first thing, BEP. This is the fact about BEP. Yeah? BEP mathematically this is an equilibrium point. Okay? Revenue equal to total cost. Right? So equilibrium point equal. Okay. So and BEP condition is not desirable by the company. So don't say, oh, because of my BEP like this, so I will set as the BEP number. This is not desirable. Okay? You need to go beyond the BEP number. Okay, otherwise you make no profit. And because the demand is keep changing, then you usually compute this regularly for your decision making. And the last part that we probably discuss in brief is that just to say that, look, BEP model is not necessarily linear. Yeah? It can be non-linear. Okay, so before we discuss BEP, let's discuss the cost component. Okay, so I have here a software cost component and engineering cost component. Okay, so the cost component for software, usually hardware and software itself. So probably if you are a software development company, you have a travel and training costs. Okay, and then the effort cost represent the salary of the engineer and the social insurance, as well as the overhead. Usually the cost of the building, okay, air conditioning, lighting, network, for example, the internet. Okay, nowadays we have AI, so we need to pay AI also. Okay, and the shared facilities, yeah, for example, the staff restaurant, the library, and so on. Okay. In engineering, if you make a business of engineering consultation, for example, these are the same, yeah, the same component of the cost, equipment and technology, yeah, travel and training costs, labor costs, overhead costs, and social insurance costs. Yeah. Now, next is the how you determine the price. Okay, so there are many pricing factors. Okay, so the first part is we call it market opportunity. That means you may quote a low price because you want to move into the new segment of the market. Okay, by accepting this low profit, okay, you are hoping you can get the profit later. This is hoping for later. Okay, another is based on uncertainty. So if you are not sure about your cost estimate, so then in that case you increase the price so that you can cover all the possible contingency problems. Or another problem is now you get the, say you go to a government project or a big company project, and then you get the contract. Okay? The contract is already set. In that case, it's just a bargain about whether you willing to accept that contract price, or isn't it? Okay, and there are also possibility that the requirement, the TOR, yeah, the term of reference is changing, right? So in that case, there is possibility that after the contract is awarded, the high price may be charged for change for the requirement for the term of reference. So some small possibility, but this is also possible. And say your company is having some difficulty financially, so in that case you want to reduce the price in order to get the contract. So these are many factors that you may also consider in the deciding the price. Okay? Now BEP is also one of the objective way. Okay? So aside from BEP, those are the other factors. Yeah. Now, in BEP analysis, the cost is divided by two parts. Okay, we call this fixed cost. Okay, F, okay? And the other one is called variable cost. So I will put as V. Okay, what is fixed cost? Fixed cost is the cost that incur in your business, even if your business do not have any production of any sales. Okay, and what is variable cost? Is the cost that directly related to the sales or productivity. Okay, so now this is the most important. Our goal in BEP analysis is actually to reduce the fixed cost and to transform that fixed cost into variable cost. Okay, I will repeat this again and again. Okay. So what is fixed cost? Example, yeah, of the fixed cost. Okay, basically fixed cost is overhead cost. Yeah, it will not change regardless how much you sell. For example, if you pay employees, okay, monthly, right, usually. So in that case, the basic salary of the employees, okay, whether you can sell or not, you still need to pay. So in that case, basic salary is a fixed cost. You rent an office space for your business, okay, whether you buy it or you rent it or you loan, then this office space is a fixed cost. Next, if you lease the equipment or furniture, okay, or computer, You buy certain software license. Okay. Okay. All these utilities, lighting, electricity, phone, and so on. Okay. Including the chemical in the toilet. Okay. And management costs, yeah, including the secretary and the boss themselves. Okay. They are all fixed costs. Okay. Maintenance, backup of hardware and software. Okay. If you own a car, okay, for your company, they are all fixed costs. The machinery for the production, they are all fixed costs. Okay. If you do marketing, okay, it is not depending on the volume of the sale. Okay, this is also fixed cost. Okay. But if the marketing is actually will create the volume or the sales, then this is becoming variable cost. Okay. So legal service, accounting service, consultation, okay, bank interest, travel, training, okay, membership of this and that, all of these are fixed costs. Okay. How about variable cost? Variable cost, okay, is the cost of the product that you sold that is completely dependent on the volume or the sales. Okay. So if you are a consultant, probably the incentive that you put per project, the bonuses, the overtime pay, the commission. Okay. So for the software development, you can directly put based on the number of code that you produce or the number of tests that you produce. Okay. So the material, the packaging, okay, for production. Okay. So this is also variable cost. Okay. Just in principle, you are telling that, okay, variable cost is the variable that depends on the number of sales. Is it clear or not? If this is not depends on the number of sales, then this is not variable cost. Again, come back here. Okay, our goal in BEP analysis is to reduce the fixed cost and that transform the fixed cost into variable cost. Yeah, this is the mantra. Okay, so what is variable cost again? The fee. Okay, okay. Sometimes we call this variable cost as COGS. Yeah, cost of goods sold. Okay, so this represent the production cost, for example, the material, the labor, storage. Okay, include the price of goods when you purchase. Okay, but you don't include the distribution cost of the sales force cost. Yeah? So if you are doing service rather than goods, so this is the same as cost of sales. Okay, the formula is simple. Okay, variable cost is the unit cost per item fee. This is the small fee here, and then N is the number of unit sales. Okay, so variable cost is the small v times N. Okay, before we go further, so can we discuss what do you think of these costs? Are they fixed costs or variable costs? Transportation material from supplier to your warehouse.
Variable.
Hmm? Yes? Let's see. Anyone? Hmm. Why
Sure.
it's variable? Why? Oh, yes. Why it is variable cost and why? Okay, Christine.
Yes, it's variable cost because you don't incur it if you well, sorry, it's variable cost because it depends on whether you're going to manufacture or create. So if there are no
Yeah.
orders, then you won't have to incur that.
Uh, simple. If you want to check variable cost or fixed cost, okay, Is there any number of sales there or number of production there? Remember, yeah, variable cost.
Yes, there is, Prof. So it's a variable cost.
Okay. So V, okay. So V equal to small v unit, okay, times n. So there is always number of sales or the number of products, okay? So how about product delivery from your warehouse to your customers?
It's
Yeah, this is
also variable cost.
variable cost. Yes. How about this one? Warehouse cost.
It depends on the arrangement with the warehouse.
No, warehouse cost is uh, warehouse cost is fixed cost. Okay, depends on the arrangement. Uh, Anything that not directly, yeah, indirectly, of course, everything go to the sales. I understand that, but uh, when we say the variable cost, it should be directly related to the sales. Okay, so all of this, okay, warehouse cost, taxes, employees training, your own profit also are fixed costs. Yeah? Your debt of the interest is also fixed cost. Okay, what is our goal again? To transfer the fixed cost into variable cost. Remember that. Okay. So, okay. Sales. Okay. Revenue, right? Revenue is equal to sales. Okay. With this, well, the same a while ago, right? So P price times N. What is N? Number of sales. Okay. Number of sales mean demand. In sensitivity analysis and elasticity a while ago, okay, that is, I put it as Y, the demand. Here is the same. I put it as N. Is it clear? So revenue is price times demand. Okay. And here is number of sales. Yeah, number of sales represent the demand. I hope this is clear. So in that case, so we have BEP. Yeah, BEP. Okay, maybe I will put it this way. So okay, the fixed costs. Okay, we draw here F fixed cost, yeah, the orange drawing here, okay, horizontal, right? And then we assume linear, okay, of variable costs. So the same thing with the revenue. So total cost is just the variable cost plus the fixed cost. Okay, this one. Okay, the variable cost is the same as the cost of goods sold. Yeah, it's the same as the unit variable cost times the demand. Yeah, it is N. N is the number of unit sales. Okay, so small v here is the variable cost per unit. Okay, P here is the price per unit. Now we can get what is called gross margin. So gross margin is 1 minus the variable cost per unit divided by the price per unit. Yeah? So this is called gross margin. Okay, and revenue is of course the same as sales, which is the demand times the price. Now, when you said BEP, okay, the total cost T, it is V plus F, is the same as the revenue. So T, so V itself, the variable cost is V times N, isn't it? This one. So, and then variable cost plus the fixed cost is the same as total cost. Okay, and then on the right hand side, the revenue is the same as N times P. Okay, because you have the same N in here, okay, in left hand side and right hand side in the blue. So then you can put it together. Okay, then you will have N equal to F divided by P minus V. Okay, so the revenue at BEP, okay, N is the demand, right? So the revenue at BEP is this value, yeah. So you can derive on your own, very easy. Yeah. So in that case, okay, yeah, I just summarize this in formula. Okay, so BEP is the same as fixed cost divided by the price per items minus the uh, unit variable cost per item. Okay, this is the formula that you probably need to memorize. Okay, simple, only two formula. One is once you know n, of course, once you know this formula, okay, then you can calculate the revenue. Yeah, remember revenue is n times p. So in that case, you just multiply. Yeah, this is n, okay, and then you multiply by p. Okay, you will get the revenue. Okay, let's practice. Yeah, let's practice so that you can get the idea. Okay, say you have unit variable cost, okay, $1.5 per item. Your fixed cost is $90 per month, okay, very, very small. And then your selling price is $3 per item. So the question is, how many items do you need to sell per month in order to reach break-even point? And what is the minimum sales revenue at break-even? Okay, practice first so that you can get the idea. Okay. Okay, open very fast. Go. So open and okay, go. Oh,
Can you see my screen, sir?
yes. So 90 multiplied
Divided
by
by
3
so
minus.
this is
Okay,
number
3
of
minus
this is the
60
formula,
items.
sir. Yes, sir. The number of
Correct.
items per is 60. Then the
And the revenue
BEP
multiplied by the price.
180, sir.
Okay. Yes. So easy. All right. Thank you. Okay. Anyone else? Oh, well, cool. There are several raise hand. Okay. Same result. So to reach break-even points, okay, you need to sell 60 items per month, yeah, the same unit of the time. And then the minimum sales revenue per month is 180, yeah, which is come from the $3 multiplied by 60 items, yeah. Okay, so let's continue this. Okay, so this is the computation, right? Now, let's practice again. Say for our social activities, we sell food at $3 per meal. Okay, the ingredient costs us $1.5 per meal. Right? Usually, food price is double of the ingredient. Now, the demand is 200 meal per day. Okay, uh, you are hiring a daily worker that costs you 5,000 pesos. Okay, so $100 per day, including you as the owner. So question is different now. Okay, how many worker can we afford to hire?
Sir, can I share my screen?
Oh, sure, sure.
Can you see my screen, Prof?
Okay.
I computed po for the fixed cost using the formula
Yes.
to this point.
Alright.
The answer is $300.
Right.
So the daily cost per worker is $100. So we can, or the owner can afford to hire 3 workers.
No, it's already have one, so
I just divide the
you can.
300 to $100.
Yes, so you already have one, so you can only hire 2 more.
Yes, sir. Sorry. There's an existing.
Right. There is existing one already, so
Yes, po.
then you can only hire 2. Okay.
Thank you,
Okay.
Prof.
Good. Yeah. Thank you. Okay. So this is what I want to show in this example is the salary of the worker represent the fixed cost. Okay. Including your own food. Yeah. As a businessman, you also need to pay yourself. Those are the fixed costs. Okay. Yeah. Thank you. Sinafi. Can I continue with the sharing? Okay. So, okay, very nice now. BEP analysis. We will know the price. Okay, we will know the revenue. Okay, at this point. Now question is there any possibility that BEP cannot be used? Yes. Yeah. So this is the point. Okay. To use BEP, okay, remember the formula a while ago? See here, P minus V, isn't it? At the denominator. Yeah, P minus V at denominator. In that case, you cannot make that negative. Right? P minus V must be positive. Yeah? So what happened if your P minus P is negative? So that means your PP is at this point. Yeah? Negative point, right? So geometrically, mathematically, this will happen at negative revenue, negative demand, right? So at this point, you cannot use BEP. Then you are telling, oh, when is this possible? Why someone put negative revenue? Yeah, but in real business, this is possible. Okay, so say example, okay, you are holding out, you are selling fashion, yeah, clothes, okay, and then you are holding out in your inventory out of fashion, out of trend. At this point, you're selling at loss. Okay, your P is actually less than the small fee, so the price is less than the one that you buy. In that case, you cannot use BEP analysis. Okay. Again, if you are holding almost expired good in hoping that you want to sell all these goods very fast, okay, so that before it expire, then you may again sell at loss. Okay. Again, you cannot use BEP analysis. Yeah? There is also possibility. Yeah? The storage cost is very high. Okay, and then your good is out of season. Okay, so you are selling clothes again. Okay, then the say winter clothes is cannot be sold at the springtime. Okay, and then you want to rent the storage, but the next year autumn is very long time. Say still next 9 months. So in that case, renting is too expensive for you. In that case, you want to sell at loss. Okay. Or unfortunate event always happen for anybody. Yeah? So some of you may desperately need uh, fast cash for the family problem. For example, someone sick in the family, someone die, someone divorce, retire, or you promise to go expensive trip. Okay, with someone that you love, or any emotional reason. So whether it is rational or irrational, it doesn't matter. Okay, then you sell at loss, right? So when you sell things at loss, okay, then you cannot use BEP analysis. Is that clear? Okay, so mathematically simple. Yeah, when the P, yeah, when the P less than V, you cannot use. As simple as that. Okay. Okay. Now, you can use Excel, okay, and try, or maybe qualitatively. Yeah? So think about this. What happens if the fixed cost is high and then variable cost is also high? What happens if the fixed cost is high and then variable cost is low? Huh? What happens if the fixed cost is low, variable cost is high, or the fixed cost is low and the variable cost is also low? So, of course, relative, cost high and low is relative. But suppose you are the business owner, say you are own logistic company, for example. Okay. Among these four options, which one is actually better for you? Okay. And if you are the employees, which one is actually better for you? Anyone? Any idea? I already give the clue. Okay. I already give the yes, Jovin.
Well, just guess, sir.
Yes, yes.
Sir, if I'm the business owner, I would like to be the third option, sir. First,
Third
fixed cost is
option.
low, variable cost
Correct.
is high. When I
Yes.
input this to the break even, if the numerator is low, it means that I just need to sell less number of items. So that's the
Correct.
minimum. Then when I'm
Yes.
the employee, sir, I want to be the fixed anything but anywhere there, but at this fixed cost is high because my salary depends on the fixed cost, sir.
Correct. Now you start to see the conflict of interest. Yeah. Okay. Now you start to see the conflict of interest. Yeah. Uh, the business owner wants the fixed cost to be low, okay, as low as possible. Okay. And as employees, okay, you want your risk to be low. So in that case, fixed cost as high as possible. Okay. And let's in the next few practices, we have 4 practices here. Okay, this will require some time to compute. Okay, I want you to take attention on this first problem first. Okay, so say you are owning a small consultant firm. Okay, you own that company. Okay, and then you hire 5 engineers. Okay, so this will do all the things. And then you have only also 1 secretary. Okay, very small company, only 5 engineers and 1 secretary. Yeah, and you also do the marketing and management stuff. Sounds familiar, right? And say, actually, this is super in pesos. Nah? I will just put this in US so that I can go. You can put this in salary in actually in pesos. Okay, so basic monthly salary is 30,000 pesos each engineer. Okay, maybe too small or too high, doesn't matter. Anyway, and then 60,000 for you, fixed cost, right? And then 20,000 per month for the secretary. And then assume 13 months per year. Okay, that is the rule in the Philippines, isn't it? 13 months. Okay. And then you give incentive 20,000, okay, for all engineer if one project is accomplished. Okay. Now, suppose you also have the office rent, okay, utilities, and other fixed costs aside from that salary. Okay, total is 100,000 per month. Of course, this one is not salary, so just 12 months per year. Okay, imagine that your average project is 1 million pesos or dollar per project. Okay, now the question is how many projects, and here is the demand, right? How many projects should you get per year to get at least break-even point? Okay, that's the first question. The second question, now if your team can accomplish just one project per year, how much is the minimum price for that project to be at least break even? Okay, so I want every one of you show your Excel. Okay, because this is continuation of several practice. If you don't do this, the others cannot do. The next part you cannot do. So that's why I want to make sure that you understand. Okay, can you do this? So the answer in Excel, I put it here like this. Okay. So I have the one in yellow is the one that you input as numbers. Okay, the other color are the one that you input as formula. Okay, so you can start to calculate, for example, the yearly salary and then the yearly fixed cost. Okay, and the BEP project, because the number of project is discrete. So if you have, for example, 4.3, you round up, yeah. Okay, round up become 5, right? So with that, so the real BEP, for example, 4 point something, now become 5 million, yeah. So then you can use Goalseek, okay, to find the price of BEP for one project. And then, this is important. Can you check also each engineer, okay, what is the income, okay? And then you can create this table, okay, on the number of project and then the fixed cost, variable cost, total cost, revenue, and then the profit, yeah. Okay, so this is very important. If you cannot do this, cannot go to the next one. So every one of you need to share. Okay, I will pause the recording for a while.
The 20,000 per engineer or the total of the 5 engineers already, sir?
The incentive here is for all engineers.
A total. Thank you, sir.
Yes. So in this case, very small, 20,000 for the first practice. Okay. Later we can change that. Okay. In the next practice. So this first practice is to tell the usual case. No? So you have the basic salary and you have very small incentive per projects. Okay.
Sir, can I try?
Yeah, cool.
So, sir, here's the breakdown, sir. We have 5
Right.
engineers, you, the manager itself, and 1 secretary.
Yep.
Salary of engineer per month is 30,000.
Mhm.
You, the manager, is 60,000, and salary of the secretary is 20,000. This is total. Sorry, sir. 20,000 per month.
Per month.
So the 13th, I just 13th month or bonus, sir. I just called it like that.
Okay, okay.
There's a 20,000 total if the project is successful. Then other fixed costs of the
Wait. The 13th month bonus
that's
is
sir,
per
the
project. Yeah,
incentive
per project, this one.
per project.
Incentive per project.
Yes.
Okay. Okay.
Then the other fixed
Yeah.
also the utilities,
Yes.
etc. That's the
Okay.
100,000 per month. Then the
Okay.
price per project is 1 million.
1 million. Okay.
So the total yearly salary, sir, is the all this 30,000 times 5
Okay.
engineers times
Multiply.
13.
Yes. Yep.
Since it's the every there is 13
Right.
months in given for the year. Then we will do the same for the manager. 60,000 times there is one manager times 13. Then
Yep.
secretary times one secretary times 13 months. So the total is this value,
Correct.
2,990,000.
Right.
Then the total yearly fixed cost,
Mm.
it's the salary, total yearly salary plus the 1
Mhm.
million, 100,000 times, this is
12.
13, sir.
12.
We will
That's
not
correct.
consider, that's correct, sir.
That's correct.
12 months per
So,
year, okay, sir. So,
yeah, because the other fixed costs are the maintenance, right? Utilities, that is 12. Okay.
okay, sir. So total is 4,190,000.
Correct.
Then for
Okay.
the number of projects to be in break even,
Yep.
it's fixed cost, which is the 4,190,000 divided by
By
the
price.
price per project 1 million minus the year project
Correct.
incentive.
Correct.
So we will get this value 4.275. It's long. So that's
Okay.
the value, sir. Then we
Yep.
will round up to the nearest whole number. That's 5.
Okay.
Then for the revenue,
Yeah.
it's
That one multiplied by
1 million times the number of projects. This is the exact, then this is the rounded up value.
right.
The 5 million. For
Right.
the price we also need to get the price for if we only want one project per year. So this is the formula. The total yearly fixed cost plus the incentive. So 4,210,000.
Okay. Yep.
Then for the income of each each engineer income per year, I just multiplied 30,000 by 13 months plus the
What's the bonus?
amount that the engineer will get for his or her bonus, which is 20,000 times the number of projects divided by they are 5 in
Right.
the group, so divided by 5. So I get the
Okay.
value of 407,102. 407,102 pesos per.
Can we make it
year.
5 because you already round it, right?
So I'll just multiply this.
Try the C rather than P. Correct.
So
Right. Okay.
410.
Okay.
410,000. Then
Very good.
total variable cost, it's the assuming
At PEP. At PEP.
BEP
Total variable cost at PEP.
at BEP.
At
So
PEP.
it's
So
the BEP at revenue at BEP minus the total yearly fixed cost. I get this value 85,510. Then the rounded up value nearest 100,000 is
okay.
100,000.
Excellent, Joven. Excellent. Okay, so you have this recording. Okay, I hope you can also create. I'll give this as assignment so that you can also continue. Okay. Yeah. Uh, yeah. Let me share my screen. Can you see? Okay, this is what Joven was showing a while ago. Okay. Now you can simulate. Yeah. Okay. The dollar now changed to peso. Anyway, so say the average the same price. Okay, 1 million pesos per project. Okay, check what will happen. Okay, you just change the value in the yellow. Okay, what happen if you decrease the basic salary of the engineer? Okay, instead of 30,000, you make it 20,000 per month. At the same time, you increase the incentive. Okay, from 20,000 per project now become 200,000 per project. Interesting, right? So now what you will do, you reduce the fixed cost, okay? You increase the variable cost, right? So this is the simulation that is important. Okay, so now the same value that you had a while ago. Okay, so the question is how much each engineer get per year? Will their income increase or decrease compared to previous arrangement? So you copy the sheet, okay, sheet 2, okay, the same sheet a while ago. So you just copy the sheet into sheet 2 so that you can compare later. And then now, if your team can accomplish only one project per year, okay, what is the minimum price for that project to be at least break even? The same question I like last time. And then that's now comparing the two, okay, scenario. What do you think about the working morale of the engineers regarding this new arrangement? Okay, so is it? Okay, show me. Anyone want to show the joint role? You can just change the numbers and you can show. The engineer will be happy. So imagine someone happy by reducing the salary. Yeah?
Sir, I just changed the salary to 20,000 and the incentive
Correct.
for,
And then
for
to 200,000, right?
Then I will just check the
Engineer salary.
engineer income. 460
Okay,
compared to 410 a while ago, sir.
correct. So you see the salary increase, the overall salary increase, okay? But the engineer salary per month is actually reduced. Isn't that strange? Your salary reduced, but you are happy.
No, sir. Because the
No.
incentive depends on the success.
Oh yeah, exactly. That's now you start to see. So by reducing the fixed cost and then putting into the variable cost, okay, the salary now depends on the success of the project, right? So that means you are shifting the risk. Can you see now? You are shifting the risk, okay, of the successful of the project or the getting the project, okay, from the employer to employees. Can now you see? Right? Okay. By shifting that fixed cost and variable cost, now you are shifting actually in terms of number, okay, the actual salary increase. Yes, that's correct. But what make them increase? Because the risk is higher. Okay, the risk is now higher. Okay, that's why your total salary increase. Okay, so okay, higher responsibility, uh, of course, will get a higher power. Yeah. Okay, thank you. Yeah. So next, what happened? Okay. What happened? Yeah. So the engineer will got slightly better, okay, better income, okay, and then the BEP price per project is also lower, right? Okay. So this is also lower risk to the owner. Okay. The third one is this is outsource model. Assuming all the price the same as previous one, so you copy the sheet again now, sheet number 3. Okay. Now you want to transfer all the risk to the engineer, outsourcing. What will happen if you do outsourcing? That means, okay, how much can you put in? Now the question is how much you can put into the maximum variable cost, okay, so that the fixed cost is minimum, okay, and the BEP is still maintained under 5 projects per year. Okay, the clue is this. Okay, you get the minimum fixed cost, yeah, including your cost, secretary cost. Okay, then assume that the rent other utilities still the same, yeah, for 100,000. You yourself and secretary still there. No change. Okay, no one get fired. Okay. So, what is the meaning of outsourcing? No basic salary. Okay, so what happened? Okay, go back to that slide a while ago, yeah, after you copy. What happened if you put the basic salary is 0? And then you use solver, okay, to create this BP per project now is almost 5. Okay, by changing the variables. Yeah. You're supposed to get this. Okay. Anyone want to share your screen? Okay. At this outsourced model, okay, the engineer income will be the highest. Okay, but at the same time, the risk it will be the highest also. So tell me, what do you think about this? What did you learn? Very simple simulation. Yes. Okay. So very simple simulation that I think this is important to give you understanding. No? Okay.
Hello, sir.
Yes, cool.
Can I share my screen?
Yes, of course. Yes.
Uh, so here, sir, when we make the engineers
5. Oh, 0. Okay.
responsible of all the sales, they
Mm-hmm.
have zero salary, and then when we go to
Yeah, you
what
do a
if
full sync.
and go seek, and then select the BEP project here,
Mm-hmm.
and then change it to 4.999, close to 5.
5. You can put 5. It's okay. To value 5. Okay.
So
5.
value 5. And
Yes. By
then
changing
change
the
the
variable cost per
variable cost.
project. Yes.
So
And,
it would
oh,
be
higher, no?
mm,
So you get 500,000
yes, sir, for one project,
per project. Yeah.
but you don't have basic salary.
Yes, but the income engineer become much higher.
Yes, sir. But high risk, high reward.
High risk, yeah, high risk, high return, right? So you can compare also what is the income for the owner. Huh?
This one.
Yes. So
Assuming we have for the owner. Let's see.
yeah.
Tools,
So
then 5.
Owner do not have a variable cost.
Oh, yes. So what should I do, sir?
Hmm?
What should I change?
Okay, so look at this value that you have here. Okay, so say at BEP 5 million, right? So the owner does not get uh, anything aside from, because all of these are costs, isn't it? And
Ah,
the owner
yes.
only gets
Yes,
60,000 per project, correct or not?
so we
The
select the
management,
first year cost.
the management and marketing, why you put zero?
Ah,
Still 60,000.
okay, sir.
Okay, so you get the 60,000 per
3,000.
month, right? This is the owner get. Okay, now what happened is, this is the assumption if you can get 5 projects per year,
Yes, sir.
right? So
Mm.
what happened if you get 6 project? What will happen if you get, for example, 7 project? So who earn more, the engineer or the owner?
Mm,
Remember, this is BEP, right? BEP is total cost equal to the total revenue.
mm.
Okay, so after this you can, oh, I think you already put that in that table a while there above in F, G, H, and so on.
FT.
In your column F, G, H, and so on, that's the profit, right?
This one, sir.
No, this one, this one. This table represent the profit for the company or the owner.
Mm.
Okay, because you put this is 30,000 and then this one is 500, so it's negative.
Mm.
But
Yes, sir.
but try to be zero again.
What would I?
Say here
Add?
a while ago you put zero, right?
Ah, yes, sir.
There. Now you can start to see. Okay, if
Mm.
five project, okay, you get
Mm.
zero. But if you have 6 project, okay, this is the profit for the company and so on. So you can
Mm.
increase until 10, for example. But when the profit is negative, okay, who actually shouldered the profit? Uh, this benefit, the loss. Who shouldered the loss? Is actually
The money.
the engineer.
Oh.
The manager, not the manager, the engineer.
Mm.
Okay, look at the component of variable cost compared to the variable cost here, fixed cost and
Mm.
variable, and then you can start to see uh, who is actually getting higher in terms of.
Mm.
So at this point, 60 times 12, 13, right? Plus 20 times 13. Is that correct? Is that the value of this variable fixed cost?
Yes, sir.
Yes. So this is the fixed cost of the secretary and the manager. I hope this is notation is correct. So can you see? Oh, this is 5, no? This is almost 0. So the
Mm.
change from negative to positive. So this is the boundary. So you can see that at this point, okay, say if you get 10 project, okay, the engineer will be much more than happy.
Mm.
What will happen if you have a 10 project? You can put one more column here probably to calculate. So, okay, how much is the engineer will earn, how much is the owner will earn, and so on, so that you can see. Insert this one.
Sorry, sir.
Insert one column. Insert one column. Shift to the right. insert. Okay, and then this one is yellow, so any value that you want to put. Okay, and then calculate everything the same. How much is the engineer salary? I think you can copy this right here. Oops. What is the formula of
Oh.
no engineer salary only? Try to check this one. C3 plus multiplied by the project or multiplied by 13 plus okay, can you put the dollar string here? Dollar, and then dollar. Okay. C ah because your salary per year is not depends on the number of projects. I think you need to change this formula similar to Chopin a while ago, which depends on this one. Okay, depends on the number of project because this is not depend on the number of project yet. So I think you need to fix that.
Yes, sir.
Okay. This one, 5. This one you multiply by the number of project. This one, right? And then you divide by the number of engineer. This one.
Number of projects and the
Multiply by the number of project. C, what's okay, and then divided by okay. By this point, okay, you can put the dollar string and then you can copy that to the right. The dollar is not include the C. You remove the dollar from the C. So that the C will change to DN. Right? I think. Okay, this is correct. C8. Okay. Can I see this formula? Okay, 13 times plus C8, where is C8? Variable cost, that's correct. And then multiply by 14, this one correct. Divided by B, okay, that's correct. Okay. So the engineer will get this much at 10. Can I see your actual value in here for 10, the profit? Okay, the profit is 2 million something. Okay, and then half of this is already paid to the engineer.
Mm.
The total revenue is actually 10 million. Okay, but you're paying to the engineer is only like 7 million. So this is based on BEP, so everything still BEP. Okay, so no real profit yet at this point. It's fine. So now my question to you is this: if you want to include the profit, okay, where are you going to put that in the BEP analysis? Hey, BEP is not profitable, right? So it's supposed to be the total cost equal to the total revenue, isn't it? So if you want to include profit in your BEP analysis, where should you put that? Any idea?
Mm,
Yeah, depends on you. So you can put the profit as a variable cost or profit as a fixed cost.
mm,
So if you put the profit as variable cost, then you need to add that variable cost as if another person, another engineer, okay, which a cost engineer has the uh, profit. Okay, if you put it as a fixed cost, okay, then you put that as a fixed cost there. You add to the fixed cost, the profit you add to the fixed cost. Okay, usually the profit is either put in the fixed cost or variable cost, depends on you. Okay? You can put in both sides. Okay, but if you put in the fixed cost, so you decide, okay, the fixed cost is how much. So that means every month, right, you want to get certain amount of money as your fixed cost, which is your profit. So you tap this. If you put that as profit as a variable cost, okay, that means you create a quote unquote a new engineer which is not in this five, okay, but now you get the number of engineer now becomes six, but the number six is actually not real, but it's actually just a profit. I hope this explanation is clear. Yeah, profit you can put either as fixed cost or as variable cost. Okay. Yeah, thank you. Thank you. So
thank you, sir.
with this, yeah, thank you, Angelo. With this, I will give you the assignment. Okay. All you need to do is exactly this. Those who already finished, so you just put the seats and then arrange and then upload. Then no more. Okay. But those who did not finish, so please make it. Yeah. So that you can do this. Okay. And of course, the this one, yeah. You need to draw the chart between the risk parameter and amount of risk. Yeah? So remember, when you reduce the fixed cost, okay, into variable cost, okay, in the beginning, okay, it will increase the morale of the employees because you can show in numbers that actually their income will be higher. Okay, so of course, the overall profit will be higher and productive, and it become a productivity based wages. So higher responsibility, but at the same time, okay, without knowingly, okay, actually there is a shift. Yeah? There is a shift of risk from the employer to the employees. Yeah? When you transform fixed cost into variable cost. Okay, so the employer will pay a higher total cost per unit. Okay, to reduce the risk. Okay, but at the same time, the employee receive that higher income per unit by accepting the risk. Okay, so when we said zero fixed cost, okay, this is basically outsourcing. Okay, that means you have all the employees become freelancer, a consultant, independent contractor. Okay. So remember, when we study BEP, okay, we are actually want to transform, okay, the fixed cost into variable cost. Okay, so start to think, okay, how to make the fixed cost lower. Okay, then you can find the variable cost by making the ceiling as constant, and then you can check the earning of the employees. Yeah. This is the clue. Yeah? The clue must be the earning variable cost must be higher. Okay? Without that, your transformation fail. Right? Sure. Okay. So, what is the risk actually? If the company have no project, what will happen? If the company have no project, then the employees risk of lower income, which is not mentioned there. Right. So, but if the company have more project, okay, actually the employer is paying more costs to the variable cost. That's true also, right? By of course, the other part is also the loyalty, nah? Because you transform fixed cost into variable cost. Basically, the employees now become a freelancer. Then they can also get from other companies rather than you, yeah, including your competitor, right? So in that case, loyalty is another problem. Okay, so the question is, how are you going to define the risk transfer from the employer to the employees quantitatively? Can you start to propose, yeah, in your assignment? Can you define the risk parameter, okay, such that, okay, that parameter, okay, will become zero for 100 risk for employer, okay, no variable cost, and uh, become one, okay, for 100 risk to the employees, okay, with no fixed cost. Okay? And then can you draw the chart between the risk parameter and the amount of risk in terms of money? Okay? That is the assignment, yeah? Is that okay? Yeah. Okay, thank you for today. And please read the slide for the next meeting. Okay. Next meeting is also, yes, Katrina, want to say something?
Yes, sir. I think next meeting is Holy Week.
Oh, wait, next meeting in the announcement. Today is 22. 29 is Holy Week.
Yes, Prof.
Okay. So, in that case, April 5, is it okay?
Reading break, sir.
Or reading break? Okay. So, when is our meeting? April 12?
12 na, sir.
Okay. Okay. So, oh, you have very long break in that case. When is the midterm? When is the midterm?
I think, sir, third week of April.
That means April 19. Okay, so become very small. Uh, do you want to have a midterm in any day? Not necessarily in the class. Is it okay?
Yes, Prof.
So that means the midterm anyway will be in Moodle the same. Okay, but I will open the midterm from 6 o'clock in the morning until 10 o'clock in the evening. Wow, nice. Yeah. Okay, so you can do it at any hour Okay, during only one day. So you decide the date to me. Okay, discuss it among yourself and ask your representative, si Abi, to tell me when is your midterm, what day. Okay, not in the class. So I will open one whole day for you. Any day that you want. Any date that you want. Is that okay? Because we missed two of this. Okay, thank you. So see you in April 12th. Is that correct? Okay, so April
There's
12th.
a question.
So, uh,
I have question, sir.
sorry?
I have
Cool,
question.
cool. Yes, yes, please.
Will the deadline for the progress report be also be moved?
Okay, so in that case, of course, move, no? So progress report is until April 11th. Is it okay?
Okay, sir.
So that you can present it when we meet again,
Thank you, sir.
April 12th. Okay, and then uh, anyone else a while ago want to say something? Okay, so see you. So in April 12th, you will have this assignment of BEP, and then you will also present your progress report. Okay. And anyway, you have a very, very long break. Okay. So happy Holy Week. Okay.
Thank you, Prof.
Thank you, Prof.
Thank you. Yes,
you.
yes. Thank you.
Thank you po.
Thank you.